Alright, so today we will be starting Unit 10, and Unit 10 is going to mainly be over graphing trigonometric functions. So today I'm going to give you guys an intro to sine and cosine curves, and you guys will have an assignment to work on after you watch these videos. So let's go ahead and label this section. It's going to be the same video for CP and honors, just as an intro. So 10.1 or 10.1H if you're in honors. So we are intro to sine and cosine curves, and we're actually going to work on these for about 2 or 3 days of class. Today should be pretty basic, and then we'll get into a little bit harder stuff when I get back for your next class. So what I'm going to start out with is the parent functions for these. If you remember, a parent function is just the simplest form of a function that doesn't have any transformations, no stretches, no flips, no translations, no anything like that. We'll start out with the parent function for sine here. It looks like this: y equals sine of x. Okay, so what we're going to do is we're going to plug in a bunch of x values into this function, see what we get for y, and then we are going to construct our graph from there. So to kind of help us out, the easiest way to do this is to go around the circle in pi over 4s to get some basic points for us to look at. So I'm going to start out at 0, and then I'm going to add pi over 4 every time, and we'll figure out where we're going to stop. So we're going to go 0, pi over 4. Next up would be 2 pi over 4, which is pi over 2. Okay, and I would have 3 pi over 4, 4 pi over 4, which is pi. Okay, we've got 5 pi over 4, 6 pi over 4, which would be 3 pi over 2, 7 pi over 4, and then we'll stop at 2 pi. And the reason why I'm going to stop at 2 pi is because if I started plugging in anything more than 2 pi, this would just be another trip around the circle, so I would start to get the same answers over again. I only want to graph like one, we end up calling this a period of the function, one repetition of the function, which is just going to be one full trip around the circle from 0 to 2 pi. So if I start plugging in values in for x right here, the sine of 0, that's on, if we're thinking about this on the circle here, that's on the right side of the circle. Okay, that has a y value of 0, so my sine of 0 is going to be 0. Sine of pi over 4, this is 45 degrees. In the first quadrant, sine is positive. That gives me 1 over root 2, which is going to be equal to root 2 over 2 after you rationalize. Okay, sine of pi over 2, that's up on the top. I get a y value of 1. 3 pi over 4, sine is still positive. We're still going to get root 2 over 2. Okay, sine of pi is on the left side of the circle, where we are not up or down at all, so the sine value is going to be 0. 5 pi over 4, we've now moved down into the third quadrant, where y is negative, so sine goes with y. And we're still 45 degrees, so we're going to get negative root 2 over 2. Okay, 3 pi over 2 is down here on the bottom of the circle, which is going to give us a sine value of negative 1. 7 pi over 4 is over here in the fourth quadrant. Okay, sine is still going to be negative there. It's still 45 degrees, so we're going to get negative root 2 over 2. And then we meet back where we started at 2 pi over here on the right side of the circle. That has a sine value of 0. Okay, so we now have a chart that's got a bunch of values in it. I want to graph these values, and let's see what this looks like. Okay, so I'm going to go ahead, and this horizontal axis here, if you notice, all of these are evenly spaced. They're all pi apart from each other. So I'm going to go ahead and I'm going to label this first point 0. I'm going to label this point at the end 2 pi. Okay, halfway in between these is pi. Okay, halfway in between both of these are going to be pi over 2. Okay, and 3 pi over 2. And then, so now I've got 4 equal parts here, and halfway in between each one of these is going to be a pi over 4. So this would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, and what you'll actually see here is the highest y value that we get to is 1, And the lowest y value that we get to is -1. And the reason why is because we see we've got zeros and ones for some of these, and then we get √2/2. Okay, well, I know that √2 is smaller than 2 because √2 is the square root of 4. So when I divide this by 2, I have to get something that's less than 1. Okay, so I'm going to put as my max y value, I'm going to put 1. And then for my minimum y value, I'm going to put -1. Okay, so if I go around and I start plotting some of these points, what I'll see is I've got 0, 0. Okay, √2/2. √1/2 would be 1/2. So √2/2 is going to be a little bit bigger than 1/2. So I'll put it maybe like right here. Okay, and I'm just going to start plotting some of these points. Pi/2 is 1, 3pi/4 gets me back to the same spot. Pi is at 0, 5pi/4 is at negative, √2/2, 3pi/2 is at -1, 7pi/4, back to here, and then 2pi is 0. Okay. So if I start connecting these, what I start to see is a wave. That is a sine wave. Okay. Let's just point a little bit here. Okay, notice I'm putting arrows at the end of my graph there. One of the reasons why I'm doing that is because if you were to continue this out, yes, it looks like this for what we've graphed, but it continues along in the same pattern because, as we mentioned earlier, if you started to take more trips around the circle, your values would just repeat. Okay, so this is why, if you ever heard this before in physics, this is a sine wave. Cosine is going to look similar. We'll graph that here in a second. Although it's going to start in a slightly different spot. What you'll see here with sine is it starts in the middle. The first place it goes is up, okay, and it comes back to the middle. It reaches the bottom, and then it finishes back in the middle again. So it goes up, down, back up again, and finishes in the middle. Okay, so there's our parent function for sine. All right, let's go ahead and let's make our parent function for cosine next. And then we will get into some of the specifics of each of these. So, the parent function for cosine is going to look like this. Y equals cosine of x. Let me paste this chart. I'm going to actually use the same x values here for this. Alright, but obviously if I use cosine instead of sine, I'm going to get different y values. So I'll keep the left side of this chart the same. We're going to go back and reevaluate what we get when we plug in these new x values for cosine instead of sine. Okay, so once again, if we're thinking about this on the circle, if I plug in 0 for x, 0 is over here on the right side. In that particular spot, cosine goes along with x. If we're thinking about x and y values, over here we have an x value of 1. Okay, pi/4, one of the reasons why I'm picking this is because pi/4, the sine and cosine values are the same for a 45-degree angle. So pi/4 is in the first quadrant. Everything's positive in the first quadrant. As we noted earlier, that's going to give us a value of √2/2. Okay, pi/2 is up here on the top. We get a cosine value of 0 up there. 3pi/4 is in the second quadrant where cosine is negative because cosine goes with x. It's still pi/4, so we get -√2/2. Okay, left side of the circle over here, the cosine of pi, that gives us an x value of -1. Okay, for 5pi/4, we're in the third quadrant where cosine is still negative. We're going to get -√2/2. Okay, for 3pi/2, that's down here on the bottom. Okay, cosine down there, the x value is going to be 0. Alright, 7pi/4, we're now back in the quadrant where cosine is positive. At 7pi/4, we get a cosine value of positive √2/2, and then for 2pi, we finish back where we started on the right side of the circle where cosine has a value of 1. Okay, so once again, if we're going to graph this, we are splitting up this axis. We started at 0, we ended at 2pi. Okay, pi is halfway between those. Pi/2 and 3pi/2 are halfway between those. And then there's another point halfway between each one of those. That's our pi/4. So we've got pi/4, 3pi/4, 5pi/4, and 7pi/4. Okay, and once again, our highest value is 1. our lowest value is -1, and we're going to go ahead and plot these and see what happens. So this time, at an x value of 0, our y value is 1. Okay, and pi over 4, we're root 2 over 2, which as we noted earlier is a little bit bigger than 1/2. Okay, pi over 2, we're at 0. 3 pi over 4, we're at negative root 2 over 2. At pi, we're at -1. Okay, for 5 pi over 4, we're at negative root 2 over 2. 3 pi over 2, we're at 0. 7 pi over 4, we're at root 2 over 2. And then for 2 pi, we're over here at 1. Okay, so if we connect these, we get a similar looking shape. Okay, it is a wave. But notice, this wave starts in a different spot than the previous wave. Okay, for a sine wave, we started in the middle. This time for cosine, we're starting up here at the top. And the first place we go is we go down all the way to the bottom when we're halfway done, and then we move back up and we finish in the same spot up here at the top. Okay, and notice again I'm putting arrows because if you were to extend this out, here's what we've got right now. You could extend this out and you would have a wave. Okay, so similar to a sine wave, this is going to go on forever and ever with the same pattern, because every time we go around the circle one more time, the pattern's going to repeat. Sine waves and cosine waves, if you extend them out infinitely, they look the exact same. You can't tell the difference between them. However, what changes is where they begin and where they end. Okay, so here's your intro for just the parent functions. We'll get into some other more specific things in the next video.